Hey everybody, welcome to the video. In this video, we are going to be setting ourselves up for future use of trig ratios, but right now we're really just drawing angles in standard position, and from there later we'll do trig ratios of any angle in standard position. I should have made the title a little bit better. I'll fix the main title on the video for the previous video. So in the most previous video, I did 2 examples with degrees, talked it all out, yada yada. I would recommend watching that one before watching this one, although they're going to be probably linked backwards a little bit. I'm going to have us do a few examples, 2, maybe 3, depending how quickly we can go. I like to try to keep it under 12 minutes if it's more than one example of angles given to you in radians. So let's get started. Again, if you need some background and support on what all these things are, what I'm referring to in the directions, please go watch the video where I did the 2 degrees, 120 degrees and 560 degrees. You'll find it. All right, I'm going to start my first angle, theta. Theta, our unknown angle, is 7 pi over 6. When we draw angles in standard position, they are drawn on top of the XY plane. I have everything kind of set up here so I can color coordinate all of the details so that everyone knows exactly what each thing is by name. The directions are actually at the bottom of the screen here. Your initial side is always on your positive x-axis. It does not move. If you want to go the extra mile and be loved by your teacher so much, you could also label your x and y axes. All right, so there we go. Next thing, terminal side, directional arrow, ba 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 ba. Okay, radians. What do we know about radians? Well, 0 degrees and 0 radians are in the same place. 360 degrees is 1 full revolution, a full circle, right? 90 times 4 quadrants, 360. In radians, which is an alternative form of angle measure, came first, right? 1 radian is equal to the angle where your radius is equivalent to that piece of the circumference of a particular circle. You connect it back, that would be defined as 1 radian. We're doing radians as increments of pi. 2 pi from our circumference formula, circumference equals 2 pi r. 2 pi is indicating that full revolution. That's 2 pi. Then that would mean halfway there is 1 pi or pi. Halfway there is pi over 2. Pi over 2, half of that, pi over 4, 45 degrees. How about, what would 30 degrees be? 30, 60, 90, pi over 2, or even pi, 180. What is 30 related to 180? 30 degrees, 180. It's 1/6. So that's 1 pi over 6. I choose that because my denominator is 6. 1 pi over 6, 2 pi over 6, 3 pi over 6. That's equal to that pi over 2, he said, right? But I'm using denominator 6. 4 pi over 6, 5 pi over 6, ding, 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 6 pi over 6, which is pi. Pi or 6 pi over 6. We're just speaking with the denominator of 6. Then that would be, boom, there it is, 7, 8, 9 pi over 6. Let's make sure we're on the right track. 10, 11, 12 pi over 6, which is 2 pi, which is a full revolution. Amazing. So that makes this spot 9 pi over 6, like we said, which is also equivalent to 3 pi over 2 when it's reduced. So I'm labeling my quadrantal angles in 2 ways, reduced and with the denominator of 6, so they're more comparable. Now I could go ahead and stick in my terminal side. My terminal side will go right there in blue, terminal side. My directional arrow, these are positive angles, so they are rotating in the counterclockwise direction. Comes out of the initial side, not out of the origin. Directional arrow quadrant that the angle terminates in, using Roman numerals because you are not a peasant. 1, 2, 3, there you go. Roman numeral 3, quadrant 3. And last but not least, one of our most important pieces is the reference angle. First, I'm going to indicate it with orange just as a little arc right there. But then I'm also going to find the measure. So R or theta sub R in quadrant 3, what we do is you take your actual angle theta and you subtract the closest, not closest, but you subtract from 180 or whatever overlaps that 180 spot. So in this case, you would subtract 6 pi over 6. So that means you're doing 7 pi over 6 minus 6 pi over 6. Love common denominators, which gives you pi over 6. So your reference angle is 1 pi over 6. And you just found all the important stuff when it comes to drawing an angle in standard position given to you in radians without ever labeling what that radian angle measure is. You really don't need to label the quadrantals, but when you're new, it's like training wheels, just do it, okay? But labeling that reference angle is absolutely necessary, and that directional arrow indicating which way you went around and how many times or proportion of times are absolutely necessary for you being able to distinguish what the angle measure is from the standard position diagram, image, graph. All right, let's do another one. Next, let's do 8 pi over 3. I'm going to move a little quicker. Theta equals 8 pi over 3. So I have this denominator of 3, so we want to speak with the denominator of 3. Okay, now your initial side, let's go. Quadrantals, pi over 3, 0 pi over 3, 3 pi over 3, 6 pi over 3, that's 2 pi. Another 3 would be 9 pi over 3. 6, 9, 6, 7, 9, no, 6, 7, 8, 9 pi over 3, sounds better. 9 pi over 3 is 3 pi. Odd pi are always on this side. 6 pi over 3 is 2 pi. Even pi is always on this side. The little tick mark should be a bit closer to the y-axis than to the x-axis if you have awareness of how big these angles are. Okay, so if it's going to go 6, 7, 8, then you're labeling, what is this quadrantal angle? Ooh, you said, I don't hate it, 7 pi over 3. I have respect for that. And 9 pi over 3. That's fine. I would say that that's fine. For a newbie, I think that's great. Next, the terminal side. Right there. Directional arrow. This one is more than one full revolution. We indicate that you don't overlap. You have an arrow pointing at your terminal side, the quadrant in which we terminate with the Roman numeral because you are a class act like that. And it's necessary. Don't write a regular too. Reference angle. Everyone's favorite part. Reference angle is always found between the terminal side and the closest x-axis. I hope you don't have this on mute. I hope you're listening and using your brain. There it's the reference angle. Theta sub r equals. So for this quadrant, what you do is you're going to do your angle here, which is in this case 9 pi over 3, minus your given angle, in this case 8 pi over 3. And that gives you 1 pi over 3 or pi over 3. So our reference angle is pi over 3, and I have that marked up in orange on my picture and in orange down here. If you aren't color coordinating, then you have to indicate somewhere. If you're not using color, you have to call it like theta sub r. Okay, that's it for now. I didn't do any negatives, but they go clockwise, and I have to maybe dedicate a separate video to that because, like, okay, we're 8-9 minutes in, because negative 30 degrees does not overlap with positive 30 degrees and you just went negative to get there, okay? Like 30 degrees is up here, okay? There's a little hot tip. Negative 30 is here, like this. It's not like, oh, go here and land there. No, that was negative 330 degrees. That's how far you swung your angle, you know? So that's important. Don't mess that up. I will try to do another video with just that stuff. So hopefully you feel a bit more confident with drawing your angles in standard position. You know how to include all these pieces. If you feel good, you know what to do. If you don't feel good, go nuts. Leave a comment. Be nice. Be mean. Don't be mean. But make a request. If it's quick enough, soon enough, I can try to do it right now. Have a good night. Adios.